So this is simplifying algebraic fractions. So we'll start with a relatively easy question here. And what we're often going to do is see what we can factorise. This does factorise. It's the difference of two squares. So it factorises as x plus 4, x minus 4. And now you can see that we can divide the top and bottom by x minus 4. When I divide this by x minus 4, I get 1. Okay. So on the top I'm left with 1 over x plus 4. So that's the first question done. The second question, you can see it's worth 3 marks, so maybe 1 or 2 more steps here. Let's factorise the top. So I can take 5p out of both of these. So 5p brackets p minus 4. 4 times 5p gives me 20p. On the bottom, it looks like I can take 2 out of both of these, so that's what I'll do. Okay, and you should look at that and think, well, hang on, that's not worth 3 marks, I've only done a little bit of factorisation. And you'd be right, we can still factorise the bottom. Again, it gives us the difference of 2 squares. Let's leave the top as it is. But then on the bottom, 2 brackets, and again it's p plus 4, p minus 4, and I can divide top and bottom by p minus 4, leaving me with 5p on the top, and 2 brackets p plus 4 on the bottom. You might be tempted to expand the bottom. Don't do that. It's better factorised. Things that are fully simplified are factorised, okay? So keep it factorised like that. This one wants us to do a bit of division, so let's keep that first fraction. We'll change it to a multiply and flip that second fraction. It's only 1 mark this, so I guess we're just going to multiply here. 2ay over bx, and nothing simplifies, so leave it there. This one's 5 marks, so I guess it's going to be a little trickier. I'd imagine the top is going to factorise, so let's do that first. So we're going to use the AC method. So AC is 6 times minus 12, that is minus 72. So we're looking for 2 numbers that multiply to give minus 72 and add to give b, which is 1. Okay, so those 2 numbers, one has to be positive, one is negative. I'm thinking 8 and 9. Okay, 8 times 9 is 72. The difference between them is 1. To make plus 1, I want that one to be positive and this one to be negative. Minus 8 plus 9 gives us x. And now I'm going to split the middle. So 6x squared minus 8x plus 9x minus 12. You'll see that that is the same as that quadratic on the top. All I've done is change plus x into minus 8x plus 9x. Now I'm going to make 2 single brackets here. So I can take 2x out of both of these times 3x minus 4. And I can take 3 out of both of these. 3x minus 4. Okay, so now that gives me 2x plus 3. 3x minus 4. If what I did is a bit of a mystery to you, you need to go and watch the clip on factorising quadratics, and that'll explain a lot more about this AC method. So that there is the top of the fraction. Now I'm going to work with the bottom. So we have 6ax minus 8a minus 3x plus 4. Okay, so let's see let's try and factorise maybe this first one. Let's see what I can take out of the first two. So it looks like I can take 2a out. And when I do that, I end up with 3x, 2a times 3, yeah. And then here, 2a times 4 would give me 8a. So 2a brackets 3x minus 4. And here, now this is a bit of a weird one. It looks like I can't take anything out of both of these. But for this to really work as any kind of quadratic, I'm going to cheat a little bit. And what I'm going to do is I'm going to take minus 1 out. And if I take minus 1 out, that gives me minus 1 times 3x is minus 3x. And to get plus 4 here, I need minus 4. Minus 1 times minus 4 gives me plus 4. So now I can factorise that as 2a minus 1, 3x minus 4. And again, if that doesn't make sense to you, go back and watch the clip on factorising quadratics, and you'll see some like that. So my fraction now becomes, on the top, 2x plus 3, 3x minus 4, all over 2a minus 1, 3x minus 4. And we get that common term, 3x minus 4 on the top and the bottom. Let's divide by that, and we end up with 2x plus 3 over 2a minus 1. And some of you might be thinking, well, can't we divide by 2 as well? No, we can't. We can't divide this separate term by 2. And we can't divide this term by 2. We can't divide the 3, we can't divide the 1 by 2. So that's as far as we can simplify. This one is worth 4 marks, so it means the top probably does factorise. Let's use that AC method again. So we're going to do 5 times 12, that is 60. Okay, so now we're looking for two numbers that multiply to give 60 and add to give minus 19. That means those two numbers must be negative, okay? Negative times a negative gives a positive, negative add a negative gives a negative. Okay, if we start to think of those factors of 60, the only two that work are minus 4 and minus 15. Minus 4 times minus 15 is 60. Minus 4 add minus 15 is minus 19. So now I'm going to split the middle. 5x squared. I'm going to put minus 15x next. That shares more factors in common with 5 than the 4 does. It would still work if I put them the other way around. Now let's do single brackets here. So 5x brackets x minus 3. And I'm going to take negative 4 out. I'm going to take negative 4 out to end up with the same thing in the bracket here. Look, I'll show you what happens if I try and take positive 4 out. I end up with minus x plus 3, and you can see, look, that's not the same as that, so my factorisation hasn't worked, so that's why I need to go, okay, change that and take negative 4 out, and then negative 4 times x is negative 4x, negative 4 times negative 3 is positive 12, and both of those brackets are the same, so I can factorise it as 5x minus 4 x minus 3. That's the top done. Now let's look at the bottom. X squared minus 9. Well, that's just the difference of two squares. So x plus 3, x minus 3. So now let's put that back into a fraction. 5x minus 4, x minus 3. Over x plus 3, x minus 3. And I can divide top and bottom by that x minus 3 factor, leaving me with 5x plus 4. Sorry, 5x minus 4 over x plus 3. For this one, we'll start with the AC method again. So 2 times minus 12 is minus 24. We're looking for two numbers that multiply to minus 24, add to 5. So one's positive, one's negative. Those two numbers are 8 and negative 3. 8 take away 3 is 5. So now I'm going to write out the quadratic splitting the middle. Then I'm going to make two single brackets. This one I can take minus 3 out and then x plus 4. So we end up with 2x minus 3 brackets x plus 4. So that's for the top. For the bottom, initially you might look at this and it looks a little bit complicated. Okay, it's actually the difference of two squares. Okay, 2x times 2x gives me 4x squared, and plus 3 minus 3. Okay, 3 times minus 3 is minus 9. So then let's write that as a fraction, 2x minus 3 x plus 4 over 2x plus 3 2x minus 3, and then we can cancel the 2x minus 3 factor, dividing both top and bottom by that, and we end up with x plus 4 over 2x plus 3. Here it looks like the top factorises as a single bracket. I'm going to take x out of both of them. So x bracket 5 minus x, and on the bottom those are both square numbers, so it's the difference of two squares, 5 plus x, 5 minus x. I can divide top and bottom by 5 minus x, leaving us just with x over 5 plus x. And a reminder that we cannot divide by x because we can't divide that 5 by x as well, okay, and that's a separate term. So just x over 5 plus x, or x over x plus 5. This top looks really similar to a quadratic that we've already had a look at. AC is equal to minus 24. So we're looking for two numbers that multiply to minus 24 and add to give minus 5. So it's something to do with 8 and 3. Okay, to get minus 5 it needs to be minus 8 and plus 3. Now let's split the middle. 2x squared minus 8x plus 3x minus 12. Make two single brackets. 2x brackets x minus 4. Plus 3 brackets x minus 4. So we get 2x plus 3 x minus 4. So that's for the top. Let's have a look at the bottom now. 3x squared minus 12x. That looks like a single bracket. Let's take 3x out and we get x minus 4 inside the bracket, which kind of makes sense because then it's going to cancel with that one from the quadratic above. So 2x plus 3 x minus 4 over 3x brackets x minus 4, divide top and bottom by x minus 4, and we get 2x plus 3 over 3x. This looks like a pretty quick one, so we've got to multiply. So just multiply numerators and denominators, so 4p squared q divided by 2qt. Let's look, is there anything I can divide top and bottom by? Yeah, I can divide the 4 and the 2 by 2, so I get a 2 and a 1. I can also divide by q, So it's just going to leave me with 2p squared over t. Nice and easy. This one looks like a bit more of a complicated one. Let's work with the top first, and we're going to do a times c. So 2 times minus 15 is minus 30, and then we're looking for two numbers that multiply to give minus 30 and add to give 1. The coefficient of x there is a 1. Those two numbers, well, it's something to do with 6 and 5, because the difference between them is 1. To make positive 1, it needs to be plus 6 and minus 5. So now I'm going to take that quadratic and split the middle. 2x squared plus 6x minus 5x minus 15. And make two single brackets. So 2x brackets x plus 3. Here I can take minus 5 out of both of them. So then I get 2x minus 5 brackets x plus 3. That's the top done. The bottom looks quite complicated too. We've got ax plus 3a minus 2bx minus 6b. So let's make two single brackets. I can take a out of the first two. Let's see, it looks like I can take minus 2b out of these two, and then we've got x, and then plus 3. Minus 2b times 3 gives me minus 6b. Yeah, and we've ended up with x plus 3 twice, which is perfect. So we get a minus 2b brackets x plus 3. So let's make those two things into one fraction. So on the top, 2x minus 5 x plus 3 over a minus 2b x plus 3. We can divide top and bottom by x plus 3, and that leaves me with 2x minus 5 over a minus 2b. Looks like we can't do much with the top of this one, so let's work with the bottom. We've got 3p minus 6t minus ap plus 2at, and let's make two single brackets. So out of these two, I think I can only take 3 out, and then I get p minus 2t. And here I'm going to take minus, and I think we can take a out, and then we get p minus 2t again. If you'd have taken plus a out, you'd have got minus p plus 2t, and then those two brackets wouldn't have been the same, and that's the thing that tells you you've got to take the minus sign out as well. So now to factorise, I get 3 minus a and p minus 2t. Let's put that back into that fraction. So on the top, 3 minus a, and on the bottom, brackets 3 minus a, brackets p minus 2t, and I can divide top and bottom by 3 minus a, and that leaves me with a 1 on the top. So 1 over p minus 2t. The top of this one, it doesn't look like the difference of two squares, so I think it's just a single bracket. So let's take x and y out, so x, y, brackets x minus 3. So that's the top already done. On the bottom, that looks like quite a straightforward quadratic. I'm looking for two numbers that multiply to give minus 3 and add to give minus 2. So those two numbers are minus 3 and plus 1, because minus 3 times 1 is minus 3, and minus 3 plus 1 is minus 2. And then I can divide top and bottom by minus 3. And that just leaves us with x, y over x plus 1. Okay, let's factorise the top using two single brackets. So we've got ax squared plus 5ax plus bx plus 5b. So out of the first two I can take ax out and get x plus 5 inside the bracket, plus, and here I can take b out of both of them, and again x plus 5 inside the bracket. So I get ax plus b in one of the brackets and x plus 5 in the other. So that's the top factorised. And the bottom, x squared minus 25, well that's the difference of two squares, that's x plus 5, x minus 5. Let's put that as one fraction. Ax plus b, x plus 5, all over x plus 5, x minus 5. I can divide top and bottom by x plus 5, leaving us with ax plus b over x minus 5. So the numerator this time is going to be the difference of two squares, so on the top just w plus 3, w minus 3. The bottom we're going to need to use the AC method for, so 2 times minus 3 is minus 6, so we're looking for two numbers that multiply to minus 6 and add to give 5. Careful, the two numbers are not 2 and 3, they are 6 and minus 1. 6 times minus 1 is minus 6, 6 add minus 1 is 5. That's one that's often people make a mistake with. So now I'm going to split the middle. 2w squared plus 6w minus 1w minus 3. And then two single brackets, so 2w brackets w plus 3 minus 1 brackets w plus 3. If it doesn't look like we can take anything else out, then we take a 1 out. Okay, so we end up with 2w minus 1 brackets w plus 3. Let's combine those two things together. So on the top, w plus 3, w minus 3. And on the bottom, 2w minus 1, w plus 3. And I can divide top and bottom by w plus 3. That just gives me w minus 3 over 2w minus 1. So this looks like a pretty straightforward multiplication, but this time I think I'm going to do some simplification before multiplying. That just saves me having to do stuff like 12 times 15 and then simplify it back down anyway. So already you could probably see there's an x on the top and the bottom, so let's divide by x. Then I'm going to divide top and bottom by 5. Divide that by 5, I get 1. Divide that by 5, I get 3. Let's do the same thing with the 4 and the 12. 4 divided by 4 is 1. 12 divided by 4 is 3. So I'm left with 1 times 1 on the top. And on the bottom, 3 times 3, which is 9. So that simplifies all the way down to 1/9. The top of this one is going to be two single brackets, so we've got 3x minus 6y minus ax plus 2ay. I can take a 3 out of both of these, so 3 brackets x minus 2y. And I think I'm going to take a minus a out of both of these and get x minus 2y. Okay, again, if you'd have just taken plus a out, you'd have got minus x plus 2y. That's not the same as that other bracket. That's what's telling you we need to take minus a out. So then I'm left with 3 minus a brackets x minus 2y. So that's the top done. Let's look at the bottom. We've got x cubed minus 2x squared y. I think that's just a single bracket, so let's take x squared out and we get x minus 2y, which is kind of reassuring because that's the same as that other factor there. Let's put it back into a fraction. On the top, 3 minus a x minus 2y. On the bottom, x squared x minus 2y, and then we'll divide top and bottom by x minus 2y, and we get 3 minus a over x squared. Two single brackets here on the top, so we have ax minus 2a minus x plus 2. Single bracket, let's take a out of both of them, and inside the bracket we get x minus 2. Looks like I can't really take anything out of these. Let's try taking 1 out, or rather minus 1, because then that gives me x minus 2, which is the same as that bracket there. So brackets a minus 1, brackets x minus 2, that's the top done. For the bottom, a squared minus 1, well that's just the difference of two squares. A plus 1, a minus 1. Let's put those back into the fraction. A minus 1 x minus 2 over a plus 1 a minus 1. Divide top and bottom by the a minus 1, and we just get x minus 2 over a plus 1. Two single brackets here on the top, so we have ax minus 2a minus x plus 2. Single bracket, let's take a out of both of them, and inside the bracket we get x minus 2. Looks like I can't really take anything out of these. Let's try taking 1 out, or rather minus 1, because then that gives me x minus 2, which is the same as that bracket there. So brackets a minus 1, brackets x minus 2, that's the top done. For the bottom, a squared minus 1, well that's just the difference of two squares. A plus 1, a minus 1. Let's put those back into the fraction. A minus 1 x minus 2 over a plus 1 a minus 1. Divide top and bottom by the a minus 1, and we just get x minus 2 over a plus 1. There's nothing we can do with the top here, so that's just going to stay as x minus 5. However, the bottom, that's the difference of two squares. X plus 5, x minus 5. Now we can divide top and bottom by x minus 5. That leaves me with a 1 on the top, so 1 over x plus 5. This one is a division, so we're going to keep that first fraction, 4 over 2x minus 3, change it to a multiply, and do the reciprocal of the second fraction first of all. Over 2x squared plus 14x, and it looks like we can do a fair bit of simplifying of this first. Let's simplify, let's factorise before multiplying, because if we multiply first, we're only going to make something more complicated to factorise afterwards. Okay, so I'm going to start with the top of this second fraction, and I'm going to use the AC method. Okay, so 2 times minus 21 is minus 42. I'm looking for two numbers that multiply to minus 42 and add to give positive 11. So 1 is positive, 1 is negative. Let's see, it's not coming to immediately. Oh, I think something to do with 3 and 14. Okay, yeah, 3 times 14 is 42, plus 14 minus 3, those are the ones. let's split the middle. 2x squared plus 14x minus 3x minus 21. Single brackets 2x brackets x plus 7. And then minus 3 brackets x plus 7. So that gives me 2x minus 3, x plus 7. So that's for the top. For the bottom, I think that's just a single bracket. Okay, so 2x brackets x plus 7. Okay, so now I'm going to write that back into the multiplication over here. So we got 2x minus 3 x plus 7 and 2x brackets x plus 7. Already you can see that we can divide by x plus 7 on top and bottom. Also we can divide by that 2x minus 3 there, which is on the top, and this one over here, which is on the bottom. So I'm left with 4 over 2x. Oh, and I can still just divide top and bottom by 2 and get 2 over x. Okay, looks like two single brackets for the top. So we've got 3xy plus 36y minus 5x minus 60. We can take 3y out and we get x plus 12. And here we can take minus 5 out and we again get x plus 12. So 3y minus 5, x plus 12. For the bottom there, so first we're going to take a 2 out. So 2 brackets x squared minus 144. And then you've got to spot that this is the difference of two squares. So 2 brackets x plus 12, x minus 12. And now we've got one of those factors from above, which we're going to simplify with. Okay. So on the top, 3y minus 5, x plus 12. And on the bottom, 2 brackets x plus 12, x minus 12, and we can divide top and bottom by x plus 12. So we get on the top 3y minus 5, and on the bottom 2 brackets x minus 12. Don't expand the bottom, it is better to keep it factorised. Single bracket for the top here, so x brackets x minus 5. On the bottom, first we're going to take 2 out. 2 brackets x squared minus 25, but don't stop there, that's the difference of two squares. So on the bottom we get 2 brackets x plus 5, x minus 5, divide top and bottom by x minus 5, and we get x over 2 brackets x plus 5. For the top here, two single brackets. So we've got ux minus 2u minus x plus 2. We're going to take u out of the first two. Doesn't look like we can take anything out of the second two. Let's take minus 1 out, and then we end up with that same thing, x minus 2. So u minus 1, x minus 2. That's the top done. The bottom is the difference of two squares. U squared minus 1 is just u plus 1. U minus 1. Put it back into a fraction. U minus 1, x minus 2. U plus 1, u minus 1, and we can divide top and bottom by u minus 1, giving us x minus 2 over u plus 1. For the top here, we're going to use the difference of two squares. So that's x plus 5 x minus 5. For the bottom, that's a relatively straightforward quadratic. We're looking for two numbers that multiply to give positive 60 and add to give minus 17. So not 15 and 4, 12 and 5. So minus 12 minus 5. Okay. Which means we can divide top and bottom by x minus 5, leaving us with x plus 5 over x minus 12. That doesn't feel like a lot for 4 marks, but we haven't missed anything. Here we're asked to factorise this one first. Well, that's easy peasy. That's the difference of two squares, x plus 3, x minus 3. And it wants us to do that for this second part here. Let's factorise the bottom using two single brackets. We've got 2xy minus 6y plus 5x minus 15. I'm going to take 2y out of the first two. And I'm going to take 5 out of these two. So I get 2y plus 5 brackets x minus 3. Put that back into the fraction, x plus 3x minus 3 over 2y plus 5 x minus 3, and then we're going to divide top and bottom by x minus 3, leaving us with x plus 3 over 2y plus 5. Again, difference of two squares for the top, so that's going to be x plus 5x minus 5. And the bottom, a straightforward quadratic. We're looking for two numbers that multiply to give negative 20 and add to give minus 1. So something to do with 5 and 4. To make negative 1, we want negative 5 and plus 4. Now I can divide top and bottom by x minus 5, and that just gives me x plus 5 over x plus 4.